Tonight you're learning about relations and functions. Functions are a special type of relationship on graphs and equations in which x only has one y value it is talking about at any given point. Relations and functions can be represented in multiple ways. Four of the ways are using ordered pairs, listing your x, comma, y. Using a mapping in which you draw a circle for all your x values and a circle for all your y values, and draw an arrow to show which x goes to which y. A table of values, which is a x and y are input and output columns to list the ordered pairs. Or a graph. Graph can either be a plot graph, or it could be a linear graph, or a graph represented with a line. Here's an example of the four different ways this information was represented. So in the Gulf of Mexico and Key West, Florida, the water temperature varies. In January, which we're represented with the number 1, the water temperature was 69. In February, it was 70. In March, 75. And in April, 78. And so I can take and draw an arrow from 1 to 69, because in January it was 69 degrees. In February, I can draw an arrow from the 2 to the 70 to represent that relationship. So as I take the same piece of information, you can see that it is represented in each of these key pieces in different ways. On the order pairs, they are in the set brackets, and then we list the order pairs in parentheses with a comma in between it. X goes first in the parenthesis, comma, then the y. So if I wanted to look at the relationship of the set 0, 10,000, 4, 9,744, 8, 8,976, 12 goes with 7,696, 16, 5,904. And we wanted to figure out what the domain and range are of this relation. Number 1, this is a special type of relation, is a function because none of your x values are used more than once. So my domain are my x values. So I'm going to set my set brackets, and then I'm going to list my x values in order from least to greatest. 0, 4, 8, 12, and 16. And then I close my set brackets. Now I'm going to do the same thing, except for with my y values, and that is my range. Your range are your y values, and your domain are your x values. So my range, again, I'm listing from order from least to greatest, and that means this last y value I have listed is actually going to be listed first in my set brackets. So that 5,904, and then I'm going to list the 7,696, and then my 8,976, then my 9,744, and lastly that 10,000. Then I'm going to close my set brackets, and now I have my domain and range when I have a list of values. By listing them, that means I'm not including any points in between. So let's look at these two and determine which or if either of them are functions. So the thing I'm looking at the most is my x values, or my domain, or my output. So focusing in on this column, are any of my x values, is there an arrow that leaves and goes to 2 y values? Well, the -3 only goes to one spot, the 0 only goes to the 7, and the 4 only goes to the 1. So this is a function because each x value is only going to one y value. So now, the way I always do it whenever I have a list of ordered pairs is I go through and I highlight or I underline or I mark my x's, because I don't need to worry about what these y values are. For determining if it's a function or not, it's do any of your x values repeat? Well, this 4 shows up twice. So this means this is not a function. If you have a graph, the easiest way to tell if something's a function or not is by using what is called a vertical line test, and is very much like the name says. You're going to draw a vertical line and look to see, does this cross in more than one spot? So here on this vertical line, as I look at it, I see that it is touching in multiple places. So this is not a function. If I draw this vertical line at any point on graph B, there is no point where that vertical line that I drew in red touches the blue line, which is the graph, in more than one spot. So this is a function. On C, if I draw my vertical line, I notice that at one spot it touches twice. It doesn't matter that it only happens once. It is not a function. Now, we've been using set notation to represent our domain and our range before. Another type of notation is called set builder notation. Set builder notation looks very similar to set notation in the fact that you have set brackets on each side, but the meat in the center is separated differently. You're going to identify your variable by just writing its name. Then you are going to draw a vertical line, and it's always a vertical line. Lastly, you're going to give a description. The description could be something like x is an even number, or it could even be something like x is greater than or equal to 5. It can be a inequality. It can be a number. It can be a description. Interval notation is going to have parentheses to represent greater than or less than, brackets to represent greater than or equal to, or less than or equal to. So the main difference between these two things is if you see a bracket, it can include that number. Positive infinity means it goes on forever in the positive direction, and negative infinity, it means it goes on forever in the negative direction. So let's practice with these. First, doing set builder notation for this graph. Looking at the domain, that means I need to look at my x values. I know this graph only shows x values being used that go from -3 through +1. But if I was to draw that graph out further, you would see that eventually every x would be used. And so my domain in Set Builder is going to look like x such that, and that's what that vertical line means, x is all real numbers. So that's how I can draw my domain in Set Builder. My range, on the other hand, no matter how I continue drawing that graph out, it's never going to go below that spot. And that point is at -1, -3. So the value that is dealing with my range, which is my y values, the key value I need is that -3. So when I list out my range, I need all values in this graph are the values that are going to be greater than -3. So I'll say y such that y is greater than and or equal to -3. So that is in Set Builder notation. Underneath this, I'm going to show you how this would look if I was to do it in interval notation. So in purple, when I want domain to be all real numbers, this is going to look kind of similar to an ordered pair because I'm using parentheses to represent I can never touch this spot. It would go from -infinity to +infinity. If you ever see that, that is the same thing as saying all real numbers. Oops, I just realized I forgot something on my Set Builder notation for range. I forgot to close my brackets. Now, doing interval notation for my range, my lowest point is what gets listed first. So my lowest y value that I am at is -3. Since I can actually be at that location, aka said equal to right here, I'm going to put the bracket, the square looking box, comma. Now, all the y values are going to go on forever positively. So I'm going to use +infinity to represent the end of that.